I'm Andreas, and that's Robin.
No.
We're from Software in Karlsruhe, which is a community of software craftsmanship interested people. We are now existing for about 5 years, almost. And we meet every month somewhere, having some food or going to a company and do some dojos there, talking about this and that. And last year, Robin presented ideas on this topic. It was not a presentation like we have now, it was much smaller, and he made a small library to show that, and today we will show you something about that. My history is programmer, agile coaching, initiating a software craftsmanship conference, and sometimes traveling around the world giving talks and workshops. And now doing it in my company inside.
Yeah, I'm a freelancer, a software developer, mainly for big enterprises, but in different areas, from web technologies to bank enterprises. And yeah, that's my experience since now, 8 years.
Yeah, so this means you can hire him for money.
That's it.
So this is roughly what we want to present today. We will talk about a little of the background, the motivation, why we did it. Then for especially those of you who are not really familiar or completely unfamiliar with JavaScript, we show you why it is relevant for JavaScript especially. We will talk about theoretical backgrounds of test doubles. And then we present what we call assume verify approach with the library Chardo.js, and at the end we can talk about, if we still have time. We will make a short break in the meantime, like this printed. If you don't want to have a short break, we don't do a short break, so we can decide as we want. Very open. If one of you has in now or in the next 10 or 20, 30, 40 minutes, the idea, I'm wrong here, this is not interesting to me, not relevant, please just go up and leave, that's no problem. It's like an open space. Yeah? You're free to leave whenever you want, you're free to come back whenever you want. You don't have the excuse, you just get up and leave, that's okay.
Yeah, for our motivation or background, there are two aspects. There's the test approach, which we like the London School of 2DD, and we want to focus on unit tests and avoid integrated tests. And the other thing why we think this topic is interesting in JavaScript is the technical aspect, because it's a dynamic language and it's a prototype-based, object-oriented language. And we will show some examples why that makes it very difficult or very error-prone to use mocks in that technical area. And that's it for our background.
The history is way back then. Who of you knows this guy? He's really, really famous. He's traveling around the world offering his help for money, sometimes even for free if it's interesting. He has a great author and a great speaker. And about 6-7 years ago, he was talking a lot about integration tests. At that time, he called them integration tests, and later he changed it to integrated tests. And integrated tests means you always test your software when all the modules are integrated, or a part of the modules are integrated, and then you test much stuff with much of combinatoric. So something gets wrong, but you don't know where. And he says these integrated tests are a scam. And you will end up in hell. That's short for what he writes there. It just will give you pain, and lots of money spent. And this is why we don't want this. How is it in your environment? Do you have lots of integrated tests that you really rely on because you don't have other tests? So, or are you more in the module unit test world where you have lots of small unit tests and you click and everything is green? Did you experience that everything is green in the unit test and then you build your software, it makes boom? Good, because this is another thing. Just for the wording, integrated tests is one thing, integration tests is another thing. Integration tests is, for today, for this session, something we mean. You test that your modules work in an integrated way, that the integration of the modules works. Integrated tests means you just take modules, units, plug them together, and then do something with the unit and check it. That's an integrated test. Testing the integrated software versus testing that the integration of the module works. Which is a little bit like haircutting and very going in the details, but it's important, I think, to clarify the thoughts.
There are two main approaches when we are doing TDD. There's two schools, the classical school, also called inside-out school of TDD, or the outside-in school, which is good described in the book Growing Object-Oriented Software Guided by Tests from Steve Freeman and Ned Price. They come from London, so that's called the London School. In classical TDD, you start writing your units from the innermost units, which are independent from the rest of the source code. So you write test and the code, and then you go to the next outer units, which collaborates with the innermost units, write the test and the code uses the innermost units you have already written. And then you go up the layers in your software until you come to the client, and then you should be finished. This has some disadvantages. One thing is that you might concentrate in the innermost units and you do over-engineering, or you implement stuff which the client never requires. The other thing, if you come from the inside to the outside of this source code, is that it might be that you do not meet the client's requirements exactly. And then you have to change the whole stack again.
Did that ever happen to you? So you program a class, you say, these are the methods, I will program, I test them, and then you write some other class who uses your just created class, and then you see, I have to change the signature slightly, I have to change the return type. It's common, right? And this is what he means with the risk of doing it from inside out.
The other approach, the London School, they do it contrary. They start from the outside, from the client side unit, and you write the test, then you write the outermost unit, and now you have another problem, because the outermost unit depend on other units, and they do not exist at that moment. So what you have to do is you have to mock the unit or create a test double and write the unit test, and after you're finished, you use the interaction between the outer unit and the collaborated or the mocked collaborator, and this gives you the specification for the test for implementing the collaborator. And then you go the layer down, you write the tests and the code, start writing the code. You notice, I need a collaborator. I haven't yet, so you write a mock for it, and so on, until you come to the innermost unit, which doesn't need any other collaborators, and then you're finished with your program, and everything should work. The advantage is that each unit is driven by the requirements of the client, or how the client is using the unit. And so you are not tempted to do some over-engineering, and you exactly meet the client's requirements.
If you really want to have examples that show this, in a brilliant way, go buy this book, read this book, it's great. I usually don't recommend books, but this is an exception.
So we favor, yeah?
Yes?
What if the client changes the requirements and that happens a lot?
Then it's a design change. The requirements or the usage with a collaborator, or what do you mean?
So you said that you should start from the end user's point of view,
Yeah.
design the application based on the requirements. But if the requirements are not complete, or they are complete at the moment of the initial requirements, but then when the user sees that in a working environment, oh, this is not exactly what I mean. I meant to have this and that, and
Then you need to change.
so you change the entire
Yeah.
chain and all the.
Yeah, but
You have to do that
But
in,
there it's no
in
difference
both.
between outside in and inside out. Because in inside out you see, the client wants something different, the customer, and outside in you see he wants something different, and then you can decide how to implement the changes. And so in the end, the resulting software, if you do the same stuff, it's no matter if you do it upside down, downside up, outside in, inside out. The software will produce what the client.
But
Or-
Maybe I misunderstood.
This is not about
Then you
change.
are supposed to write more unit tests,
No,
or
it's in probably
or it's the same.
unit tests as if we learned it in the past. It was going from the inside to the outside. It's like Uncle Bob preaches it. You create some class, some method, then you test the method. And then on this tested code, you build up the next layer of code, the next functionality. So you always build up on already tested working stuff. And they say, let's do it from the outside. Just put something up, use it, and of course, then we play wishful thinking. We say, we need a collaborator here, we need a service like that, a controller here, and we just call them, but we cannot call them because they're not there yet, so we mock them. We just write some interface in Java, for example, or some class which has no implementation. Then we say we call this method, then we define the method, but we don't return something useful, and we mock it away. And then we work our way inside. It's just the creation of the code, the design happens this way. It's a way of designing stuff, and not a way of really implementing stuff then in a specification way. It's really how do we drive the interfaces of our classes? Upside down or inside out.
And the cool thing with outside in, you have the interaction between the client and the outermost units, and then you can create the first mocks for the UI, and you can gain the feedback from the customer. And the other way around, you can show it the customer when the program is finished, when the software is finished, and when you then have to change something because the client says, no, I thought it should be different, then it's a lot of
Yeah, of course, that even when you only have the outside layer, if you mock the rest away, you can show it to the client. So he can prove that at least what he sees works as he wants it. And we will show examples of this stuff and how we do it later, anyway.
Yeah, and we find that a really cool thing, doing TD in that way. Usually you have a mixture of it. Sometimes it's better to do the classical approach, and sometimes maybe this approach does better fit.
And when you have existing code or legacy code, then it depends. Sometimes you do this, sometimes you have to change inside because you know there's a bug, then you change it, and then you have to wait to work out to write additional code for this fixed bug or something because it has consequences somewhere else.
A question?
Yes. So, where do you actually start if you start from the outside? What you were saying before is about user interface and so on. That's completely from the outside. But if
As close to the user interface as it is possible, or in a good relation to the costs you have. So my preference is usually starting on the UI controller, so I can do it in code and don't have to use additional frameworks like Selenium. So we set up everything because the setup is quite expensive if you really check the rendered stuff in the browser. So my preference personally is to start just directly below and just have a very stupid user interface, which works if you don't have logic in the user interface, if you don't have rich clients with Angular or React, then it doesn't work, of course. But then you can check the interaction like microservices that are, or the services that are called from the rich client. And
Right.
do the rich client test yourself with a mock backend.
My question was mainly motivated from not binding to the interface yet, not having to make this decision yet. So I'm wondering what your thoughts on that are. Because you answered it.
You have to make one first decision anyway. At any time you have to say, I decide the world is like this, and then you start. So the first thing is an assumption, and then you work from that. You just say, this is my user interface. Somehow. This is the method which is called with these parameters. That is my outermost method. And from there you can work your way in. But the first thing is an assumption. You just define it because you're God, you can do it, you do it. That's what is the outermost layer. That's why we're all programmers, because we want to be God, right? So it looks like food now.
Yeah, spinach.
So you want to talk about it? Should I?
The
I don't-
idiosyncrasies of JavaScript, yeah. I think if you do not know JavaScript, you can summarize it in a funny sentence. That says, meat tea is much more wholesome if you replace it right before serving with spinach.
So you mean I go to a restaurant with my girlfriend,
Yeah.
and my girlfriend, she really likes meat, yeah? It's an exceptional girlfriend, and she orders lots of meat tea, and I think, no, she needs some healthy food, not always this junk food, and so, but I don't want to argue, you know that. So she orders some meat tea, and the waiter is happy to order meat tea, and brings meat tea, and he places it on the table, and she takes fork and knife and starts, and suddenly it's spinach. That's JavaScript. You just replace completely what is there like magic. That's what JavaScript can do.
And that's really cool if your girlfriend does notice it. If
So-
she eats it and she thinks it's meaty tea, that's great.
Yeah. Maybe then you should look for another person to share your life with.
Yeah. Maybe if she noticed, then it might be the bad thing of JavaScript.
Or
Because-
if you replace me by you and she doesn't notice,
Yeah.
yeah, problems.
Maybe you get a runtime exception,
Or runaway exception.
runaway exception, or something like
Never
that.
know. Yeah, so it is cool and spooky at the same time. It is really powerful, but you can make really big holes in your body parts or somewhere else, or kill colleagues. That's really dangerous in JavaScript. At the beginning it looks very, very simple, but JavaScript has a big boom.
Why is it so? JavaScript is a dynamic language, so you have no strong typing. So when you have a function with 2 parameters, you do not need to call that function with 2 parameters. You can call it with 5 parameters
Yeah,
or with
we
no
show that in the
parameters.
code.
Yeah, and you do not need to have the type which is expected. So if you have a function for
No.
string, you can pass a number, and maybe it works, or maybe you get a runtime exception, but you never get a compile exception because
No.
that's a dynamic language.
Yeah.
And you can create objects on the fly, which is okay, but you can also change the objects on the fly. So even if it looks like a specific type, it doesn't mean it has the same properties as you expect this type has.
Yeah.
So it's very powerful, but can be very error prone.
Yeah.
Let's show some examples.
Yes. So is that readable? So what we see here is just what you can do with objects. I'll show some. Here it's always with console logging, which is system print line in Java. And so, of course, if I do something like this and I let it log, it gets out like this, and this means I am an object. So we have a literal to create an object, and the object is of the class object. And that's very, very simple. If I want to have an object with some field, I just declare it this way. Every one of you who knows JSON thinks this looks like JSON. The only thing is you have no no quotes around the parameter, around the field name, which is just then converted to a string automatically by JavaScript. So you have a field A with a value of a string value, and if we print it, we will get this object. Of course, we can assign an object to a variable, and if we print out the variable, it prints out the object. And now we have this object, we can assign additional fields. How cool is that? In Java, we cannot do that. Once the class is defined, the class is defined. We cannot change the structure of the class because we have a class. Here we don't have a class. We just have a prototype. That's why JavaScript is called a prototype-based language. We just do it, and then we can change it. So we make a new field, slot 1, and then when we print it prints out 2 fields. Okay, so a key needs to be a string. Good. And an object almost feels like a map in Java. Yeah, so it's more a map than something else. A map with some objects as keys and some values, which are also objects. But the keys, in fact, can only be strings. You can put in anything as a key as long as it is interpretable or compilable, if you can call that in JavaScript. But it automatically makes a string out of it. So if you want to have a key with length, you have to use another notation, not with a dot, but you can use like an array notation, which you know from Java. You can even put an object as a key. And what happens is the key with length looks like this, and the object is just the toString method of the object. Simple as that. And now it's getting spooky, because what I can do, I can change the structure of my object once I have the object available, and I can delete fields in my object. And I can put new fields to my object. And this function here is just to show that inside here something happens. I put the object in, which is a parameter. And even there, I can change the parameter. And if I lock the original object is changed. Yeah, passed by reference, which is expectable. But the delete, in the beginning, when I was first dealing with JavaScript, it was like, oops, I wouldn't have expected that. So this is the thing what we mean with you can replace it by script. Yeah, everything what's in the object, once it was created, you cannot rely that once you get it, it's still in. Yeah, something in the code could change your object in a completely unexpected way. The other thing is the functions. Who of you would say that JavaScript is a functional language? Why?
Because functions are accessible syntaxes.
Yes, and this means that you can have a function as a variable, and you can partially evaluate functions and return functions again. And this is really, really powerful. But what is spooky, again, if you're not used to it, once you get used to JavaScript, you don't see that anymore. But in JavaScript, you don't have something like method overloading, because you don't have parameters. You don't even have return values. If you look at the signature, it says, hello, we have a function, that's the name, and because it's a function, we need these brackets here, that's it. And then we have an invisible thing called arguments, which is an array which is always there, and I can always say, I want the second argument, and do something with it inside the function. That is part of the language. So these arguments here is part of the language. So I call now the function with the object named Peter, and because it prints out the first argument, it will print out the object. And the next thing, what surprised me in the beginning was, if you declare something again and again and again and again, it's okay. JavaScript doesn't complain. So it just replaces the previous declaration. So if you want to declare something in a context, you don't have these curly bracket contexts like you have the blocks in C or in Java. The only context you get is in a function. So you have to create a function, like here, and then you can create another function with the same name as above. And then we have a named parameter. So this is just for easier access, so I don't have to say argument 0. And then we call the function, and it prints out this when we call the outer function. So I can just let it run. That was Control-Shift run. And then you see the printout, just like promised. And for those of you who don't know JavaScript so well, or who didn't know it before, what will happen when I remove this? What will be the printout now?
Both times it will print new something.
Correct. And this is, in the beginning, when you're new to the language, like, what?
Yeah.
So, in the back end, with Node.js, for example, it's not a big deal because in Node.js you have to declare all the files you rely on. But on the front end, you just include JavaScript files in any particular order, which is relevant, but it is any order, just as the way you write it down. And so you use some function from some library, but you don't like that. So you write a small JavaScript file, you import it as the last one, you overwrite the definition of the function, and then you have a different declaration of this function. And this function can be used somewhere. And this is what it means to have code injection in JavaScript on the front-end side. So not only you as a developer can do it, also the user can probably do that. You can just open the console and rewrite the function. And so you never can be sure that the front-end JavaScript you deliver to the user is really the code that you deliver to the user when it's running, because the user could have changed it, even in parts where he's not supposed to do that. So far for JavaScript. And this is why we think this language is particular, it's special, it's also dangerous, and we need to take care about making a safety net for the holes we can trap in.
So developing a JavaScript program without TDD or without tests is crazy.
Yep.
You will not survive a long time.
I do crazy for a few years now.
Yeah.
So
Okay.
It
Crazy.
works as if you are if you get used to applying well-established rules.
Yes.
You have linters.
Yes.
You have
Discipline.
discipline.
Yep. Unwritten rules. Yeah, which is discipline. So you just follow conventions.
Yeah.
That's what really happens.
So back to now to our problem. We don't want integrated tests because of the combinatorial explosion, but we know that we need some kind of integration test that our units can work together. We like the London School of TDD, which leads to many isolated tests, which we really like, but in contrast to that, it also leads to a lot of test doubles.
So heavy Martin. You had a question.
Yeah, so you are referring to JavaScript as a dynamic language now, and what is that different with other dynamic languages like Ruby and Python?
I'm not into deep in other dynamic languages, so I suppose many of the things are the same, some things may be different. But JavaScript is really special in the way that it has these prototypes. And is not really closed objects, so you can really grab everywhere.
Yeah.
Test tuples. Who uses the word test tuple, test double every day in normal life? Probably nobody of you. What word to use? Probably mock?
Yeah.
Yeah, we are all in our everyday world, we are talking about mocking. Especially in Java, we have this mocking framework called Mockito, which is our godfather of mocking all things the way we need to mock. But in fact, we have different flavors of test tuples, and I think it's worth to reflect a little bit about why are they different and what is their purpose. I will show you code examples based on this very trivial class. It is a class A that has one collaborator, class B. Class B is injected in the constructor, and the method we want to focus about is an interesting method which just asks class B help do the work and checks if this is smaller than 10 and returns the result. Is it smaller than 10 or not? If we do stubbing here, it means that we replace class B by something else, and often we do that very simple with Mockito. Examples are in Java, I guess you've already found out. And very simple, if we just stub the class B, it will automatically stub all the methods with default implementations and default return values, which are 0 if it's a number, which are null if it's an object. And so in this case, we can just call a new class A with a stub, say an interesting method, and it is true, because 0 is smaller than 10. Simple as that. What is the difference to the fake object? The fake object is a or dummy, is a really similar thing, except that we do it manually, often because we don't want to use a mocking framework, or because it is a real big thing like a database. So we have a real database, and we have a fake database. And the fake database probably has dictionaries inside, which delivers values, probably something like that. And a fake object in this case could be implemented like that. We make an anonymous subclass of class B, override the help do the work method and return some value, and then the call is the same. So this is the difference between a stub and a fake. Then we have a spy. And the spy is interesting because we do not focus on the system under test, which is our class A. We now focus on the spy. We want to know, did class A use the spy, which is does it use class B in the way it's supposed to use class B? So here we verify the spy and not the system under test. So if you go back here the verification goes to the system under test, and here the verification goes to the spy, which is the main difference. And the spy looks different if we do it manually. We need a named subclass of the class B, because there we need some state. Of course, we could move the state outside in the test. We could do that, but here in this example, it was not so simple. And then you instantiate the spy, you call it, and then you assert that the spy was called. And you don't care about class A anymore. Of course, you often combine it in one test, but then you have two concerns, which is against Uncle Bob's rule of separation of concerns. If you go in a very orthodox way. And last but not least, we have a mock. And the mock is a thing which, depending on the framework, you either program before you call it and tell the expectations to the mocking framework and say, once you run the test, I expect this method to be called, that method to be called. Or in Mockito, you have to do it afterwards, which looks then like this. You create a mock like we did with the stop. You call the function, and then you tell the mock to verify that help do the work was called. So the focus is again on the fake, on your test doable, and not on the system you test. Yeah, so this is a really important thing. So we have these two types of test doubles that just replace some real things because we just don't care what they do. We just want to program our system in a way that the system under test is testable. And then we want to test really that the system under test is working with its dependence in the way we are expecting to work with its dependence. These are very different things.
So, is there a deeper difference between spies and mocks, except that spies are manually written, whereas mocks?
Yeah, the
A deeper
mock-
difference, not. It's a detailed difference.
No, it's you can use a spy which then calls the real implementation,
Yes.
and then you only verify that it is called.
Okay.
While a mock is more a mixture of a spy and a stub because you return values.
Yeah.
Yeah.
A spy is more powerful.
Yeah.
So, what is your usual way of using test doubles? Which color would you choose for your daily work? What is most things you do? Stubbing, spying, mocking, faking?
It's a combination of mocking and studying.
Okay. 50-50 or more stubbing, more mocking?
It depends.
Okay. What are your experiences? No mocks at all?
Mostly mocks.
Mostly mocks?
Yeah. Occasionally just dummy objects.
So you really verify the interactions.
Mostly.
Cool. And who of you is working with legacy code? So big code bases where you often stop away parts of the stuff. And did you ever see something like this here?
Yeah.
So blah 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 means more test code, doing this, doing that.
Oh
Yes. Is this stupidity or is this just happens? Sometimes it just happens.
yeah. I have the impression it's stupidity.
Yeah, sometimes it's just standard and think, oh God, what have I done?
When I see that, I already know that the code hasn't been written with testing in mind.
Yeah.
I think that is also why mocks have a bad reputation for many people, because sometimes it happens that we test the mock but not the code which we should test.
This is still nice. What I usually see is you have 5 to 10 classes that are mocked
Yeah.
in one test.
Yeah, and that one mock requires the other and returns it and stuff like that. Yeah.
Crazy.
The main reason why this can happen is because if you just see the variable class B, you don't see it's a mock. You don't see it's a stub. Because it has a name of the real thing. And then it's very easy to make a test because it's a real thing. Name looks like a normal class B object, so it must be a class B object, I can test it. So one safety net is to use good names, so you call it class B mock or class B stub. Then sometimes it gets long. But if you're in an enterprise world, your class names are long anyway. So back to food, right?
Back to food, yeah. So mocks sometimes testing with mocks sometimes if they are not used correctly are useless. But still, if we use mocks correctly, we may have a pain using it. why is it that way? When we using test doubles, we always make some assumptions about the real world or the real code. For example, we have an assumption that our waiter who talks to a chef, that the real chef understands when he's asked for menu number 42, and that the real chef returns something like a slice of pizza. So these are two assumptions, and there's nothing wrong about that. But this test works now with the mock chef. And if our assumptions are not correct, then the test is green, but the real app, the integrated app, doesn't work anymore. Because the real chef doesn't understand menu number 42, but menu 42. And he doesn't return a slice of pizza, but the whole pizza. And now we should have done some implementation, the waiter, maybe. Maybe he should take a bigger plate, or he should cut the pizza for himself to serve it to the client. And but our test says everything is good.
And the waiter represents the user interface.
Yeah.
In this case.
So yeah, let's correct our test so that the test double is used if it's the real object. And now everything seems to be okay again. The real app works and our test works. And now, with the time, our code is changed. We have a new menu card, and when now the chef is asked for menu 42, he turns pasta instead of pizza. And because our test was green, still green, we have forgot to adapt the implementation of our waiter. Because now maybe he has to serve the plate with a spoon instead of a knife. So that's a problem. Unit tests with mocks, they can become mocks itself. So what do I mean? They say everything is okay, everything is green, and we rely on it, but in reality the application is broken. So we need something like an integrated test where we test both the real chef and the real waiter.
You mean like here?
Yeah.
So that these are like mirrors.
Yeah. And
so the word mock means something like mimic. I mimic a behavior. I pretend to be a swan. Yeah? And if I do it really, really good, you believe me. But if I don't do it good, don't believe me. But probably I'm a sufficient swan for the context here.
what do you see here?
What is this?
Obviously.
You could be clever because it looks like. It looks like what?
An image in a mirror.
Yes, it looks like a piano in a mirror. This is what's in front of the mirror. So, usually for our testing we don't care what it is, we just care what it pretends to be. If it's close enough for our testing reasons, then it's okay.
Yeah. So only from that perspective it's maybe okay. So from the perspective of the test, it's okay. But in another scenario, it doesn't work anymore.
But if you want to play on the piano, you're lost.
Yeah.
So the real object does not behave as this mock, because the real object can do much more
So
in this case.
yeah. So we what we can do, or when we want to test successfully with mocks, we should be aware of that, and we should ensure that our mocks work like the realistic object. That doesn't mean it exactly does the same thing, but in this perspective, it makes something useful, something which makes sense. And we should ask ourselves, are our assumptions correct? And does the real object really behave like we assume?
Yes.
And this is what we call the assume verify approach.
Yep.
How we can do that.
We can also do just short question. We could do a short break now. We could do a short break later, or even later, or we could not do a break at all. Who wants to continue? Looks like it's more than the others, and we just continue.
Okay, the assume verify approach is very simple. We could also only use integrated tests, but we don't want to do that. So what can we do? Whenever we write a test and we use a test double, what we also should do is write a test for the real chef, for the real collaborator. And what we are doing is we use the same parameters and check if the same thing is returned. And we say the test with the mock is our assumption, and the test with for the collaborator is our verification. So we just do everything twice.
Okay, so the collaboration is called, the test with the collaboration is called the assumption, and the assumption is also stubbing or mocking the test double, and the verification is the real call on the real implementation.
That's easy.
Okay, basically you have to keep track of this and make sure that you always
Track
follow
is
this
it.
rule.
Track, yes. We record that. We have a big old 80s record machine connected to the Mac. No.
So yeah, what you're doing now is you make assumptions and your verifications, and your verifications maybe in another source code than the assumptions, because it works on the client server side. And after you have record everything, you match all assumptions and verifications, because there should be, for every assumption should be at least one verification corresponding, and for every verification there should be at least one assumption. Yeah. So you match them, and there where you do not find a match, these are your test gaps, and you should have to look closer and decide if there is an error, if you have forgot something in your test code base.
How can you make sure? Is there a way to automatically verify this?
Yes, that's the library we present.
Yeah, usually by now we always made this by hand, intuitively, and that's it, because by now there are not many tools, because in Java I do not know anything.
It's hard to do.
In dynamic languages there are some tools. I know in Ruby there is Bogus, and in Clojure Midge, but
And I'm naive.
and yeah, so when I tried to learn JavaScript, and I was inspired by the talk of Reinsberger, I made a small library, and which helps me to keep track of the assumptions and verifications.
Yes, and because we said it's a live coding session, we show some more code. And this is just a normal JavaScript test. For those of you who know sign-in and must, and this describe it, should, way of doing things, this is just normal stuff. So what we're doing here is we are defining a collaborator which has one function, is valid URL. We have a blacklist that defines two members A and B. And our system under test has a function is OK, where we inject the validator, we inject the URL to test, and then we delegate to the URL validator and let him do the real check and return it. Okay. And then this is to reset mocks, the mocking framework. It's just glue code. So then we stop the collaborator, we say when is valid URL is called, please return true. And then suddenly, if we do it on the system under test and say, is it okay? Is the URL C a valid URL? He says, yes, it's a valid URL. Surprising for somebody? Or straightforward? And if we do stop with false, everybody wonders that false is returned here. But this is just a matter of stopping. Okay, then we make a validator which is different in the way that the first argument now, where is it? Oh no, the first argument is URL to test, then the blacklist, and it returns the index of the URL to test. We inject it to the validator and say test it, and something happens, and then we really build it up in a completely integrated way, and it happens. So this test is currently skipped, and the other tests I will just run it, and you see the tests are all green and one is ignored. So now we have somehow the idea to change the validator so that the validator's function is valid URL first gets the blacklist and then gets the URL to test, which is a string and an array, which is not a big deal. And if we now let these run, all tests are green, and now I have my new integrated test, and this failed. Why does it fail?
Doesn't have the blacklist.
The blacklist is in the validator. The validator gets
The blacklist is defined.
Yeah. It's defined as a
yeah.
almost global variable.
Okay.
It is because we swapped the arguments, and now it is checked, is the array an element of the string? Which is completely sensible in JavaScript. JavaScript doesn't complain, it just says, no, an array is never a member of a string. So every URL suddenly is valid.
So if we would have used another integrated test, but for the C, which should be false, there would be everything okay. For C, then there should return true. No, it should return true because that's not in the blacklist.
C was true, yes.
Yeah. So let's run it again. And we have the integrated tests and the unit test, and we think everything is okay. But yeah, we have missed something in
Oops.
our test suite.
Not good, huh?
Not good. So let's do the same with the assume verify approach.
Your playground.
So what we see here is initialize the library and some helper functions. This is for our assumption, and this is for our verification. We have our collaborator, which our test double, we have to call create double because we have to give an ID that we can identify them, the test double in the assumption and in the verification later. So I have to call the test double created like here. So here, after we have run our test suite, we will log a report of Chardo. So we have informed about assumption verification if everything matches. So when we want to define an assumption, it's just how we read it. So we assume that our collaborator can handle when it's called the method isValidEarl with the arguments C and blacklist, and then the collaborator should return true. So collaborator point isValidEarl with C blacklist is true, and when we call our suit and call is okay with the collaborator and C, this is true. That's like in the example, in the previous example with signer, the same. And here too. And now the other part, the verification, when we implement the real collaborator, we make a verify. And now this is why we needed the createDouble method, because we used the ID to identify the collaborator, and we say we want to verify that the real collaborator can handle isValidEarl with the arguments C and blacklist, and that it should return true, and he should do this on the real object validator. So let's run it. It was
Control Shift.
yeah. So let's have a look at the code. So we now have two assumptions which have been verified and two verifications which have been assumed. So yeah, that is what we expected. So, but what happens if we change the parameters? Let's run it again.
Everything green, like in the other
Everything.
example.
But we now have a warning that there are some assumptions which haven't been verified and some verification which haven't been assumed. And now we know that our assumption does not correspond with the real world, that there's something what we have missed. So yeah, and if we look at that, we really we see, okay, here we assume that we call it with A and then the array, and we verify that we first pass the array and then the string, so we know there is a gap in our.
It's a good indication of where the problem could be.
So let's go to the next example. Here we have now. Do you want to do the step?
If you want to continue.
Okay, let's do another example. We have a calculator and a printer, and we want to print something, pass the calculator to the printer. So whenever the printer is called with a number, the printer calculates something with the numbers by passing it to the calculator, who returns 45, and then we print the same with euro appended.
The business story is to calculate some discount and print the final amount.
And yeah, so that is easy, and that too. So let's run it. We have everything is green. Okay, perfect. So here are our unit tests, and now we have also a test for the calculator, where we where we create the recalculator, and that works too. And our integrated test is with the real printer and the recalculator, we call the printer print 120 and 10, and then it returns 108.
Yeah, the one test is skipped because it would fail currently.
Yeah. So what we see is we have this unit test with 50, 10. We have a test for an integrated test. And now let's run this test. Oh, it doesn't work. Why that? So the recalculator, when we pass 50, let's have a look at the implementation. Here, the recalculator expects 2 arguments, price and discount, but we called it only with 1 argument. So the discount is not a number. So 100 minus not a number.
Or undefined.
Or undefined. Yes, undefined is not a number.
Yeah.
So we get actual not a number. Yeah, that's the surprises of JavaScript.
Mhm.
So let's do the same with Chado, where we again make here our assumption and just run it first time. So now we have here our assumptions for the unit test. Then we have our integrated test, and and we have 1 test for the calculator, which verifies the assumption. And we know 1 assumption wasn't verified. That is because we have skipped this test. We should write that too, or run that test too. So, and now we get the error not a number. But the difference is that we have been reminded to write this test, because we know one verification was missed, and then we write the test, and now we know, okay, there is a gap in our code, and now we could correct it.
So what we did is in the printer, if you scroll a little bit up, no. Here in the printer we have 2 tests, one with 2 arguments and one with 1 argument. And then we were stubbing the collaborators, which is the calculator, and everything was fine. But if we would have used it in production with a real calculator, it would have crashed, because a real calculator cannot deal with only 1 argument. And so on this way you see, oh, you're doing a test for something that is probably not tested. So you stop something which is never tested. This is a cool thing.
So, yeah. Okay. So what we want to do now is a more long example session with Chado, a small restaurant simulation, which symbolizes a layered architecture. So our client talks to the user interface, which is the waiter who takes the order from the client. He then talks to the chef to cook the meal which was ordered. The chef fetches the ingredients from the pantry and makes the menu and gives it back to the waiter, and the waiter gives it back to the client. So a typical layered architecture.
Yeah.
For example, if our client wants to order a pizza tonno, the waiter takes the order and translates it into an internal ID. So says the chef that he should cook 142. Then the chef knows which ingredients he should take from the pantry. He makes it and he returns the object pizza tonno, and everyone's happy.
Yes. So we would do a round trip. So we go from left, each step to the right, make a change on the left side, and see what happens when you do the assume verify approach. And then we would do a change on the right side and see what happens there. That's what we'll do. We do coding now, and you can do coding with us if you want to. We have virtual machines with us, which you can install if you want. So you have a virtual machine, and you can just play with us, and we would just wait about 5 minutes so you can install it. Somebody wants a virtual machine?
I would like to apply on my application. Let's see if that works.
So just have to say yes, and you get a USB stick, which I want back, so you cannot keep it. But we have it prepared, if I find them. There's one. I have even two. And there's a virtual machine installer for different platforms, as long as it's Windows 3.1. No. Huh? Anybody have a clue how long we can do the session here? Because everything moved.
Until 5:25, I guess. That's
Yeah, it's the official.
Yeah.
Yeah. So let's just do the session until someone comes and kicks us out. Or if they're all really fed up with it.
It seems to me that this tool doesn't work if you don't have something like input-output for your mocks. I mean, it works for stubs where you actually have to stub the return value. If it's something like void, then you can't verify that. You need the output to verify that.
No, if it has void, then it works also. You just check if it was called.
Yeah, but well,
With a
here's a simple case. Let's assume that you have some code that has to call the print line method or something like that, and you verify that the method has been called on some console object.
yeah.
And then the console object changes and says that you have to call the flush method after you call print line in order to display something.
No. Yeah, that's. Of course, we cannot foresee protocol changes. If the protocol changes, that's not
Yeah.
the scope of this. You're right. So, in former times it was one call, and now we have to do two calls, right?
Yeah.
Yeah, that's not yet implemented. You can do that, it's open source.
Yeah, you would need a way to describe the output, which is not a return type in this case.
Yes, in this case.
Yeah.
But there are many special cases you can imagine, like output, like database interactions, and so on and so on. So, of course, there is always room for extensions. But we primarily focus here on giving you thought input, so you can think about your way of using mocks, and to show a proof of concept how it can be done in JavaScript in a not so complicated way. It is not many lines of code what the library does.
No, it's very small, and it's only a showcase. No, it's not for production use. But if there are people interested, you are invited to to make it
You
productive.
need a password if you want to start the VM, and the password is reverse. Reverse. You wanted a VM too?
No. Can be.
Yeah, reverse light. Thank you. Everything small, just reverse. I shouldn't have done the update yesterday or the day before. Assuming it doesn't work anymore. Quiet. Any progress in installations? So on the lower left there is a web storm once we started the image. Yes, and then they should be very, very self-explained. So you can have this way.
If it were mine, I would do that.
And you should see something very similar to that, where we have the 6 steps we want to perform. And we start from the outside, like I would be the customer, talk to my code, and my code is represented by the waiter, which is the user interface.
You start?
Hmm?
Okay, let's open the first file. So yeah, we initialize our variables need for doing the assume verify approach with Chado. We describe our pizza restaurant, and this is again our console report after our tests have run. And we start with the client or the customer. And because we do not have a waiter yet, we haven't implemented it yet, we just create a test double. And now we make our first assumption what our waiter should do or can do. If our waiter is called if on our waiter the function order is called with the argument pizzatonno, then he should return pizzatonno. And that works. We just run it. And our implementation is not yet finished because there is one verification missing.
So
Okay.
this shows you how you would start in the London style, which represents here the user interface somehow. It's the outermost interface we want to talk to, and this call here would be something, the outer system, which comes from the outside, where you start programming, and that's why we do a dummy call to waiter order. If you comment it out, the waiter order line, then we would see a message in the console that some assumptions are never called, because we don't have any real use for this, so it is probably unused code. We don't have that on the virtual machines because we just implemented that yesterday. All right. So now we could do the verification, right?
So yeah, let's describe our waiter. So it can
Handle an order.
handle an order. So now the first thing is that we now need a real waiter. Or we just say we want to verify what we assumed. And now I need the ID of the test double, which is the waiter string. And the rest is the same. I could copy it from above.
The reason why it is so much blah blah is because the verification and the assumptions can be in separate files, which is very, very common because you do tests for the one thing here and tests for the other thing in the other test.
You should have a similar instance of Shadow, or
If you
how
let,
we
usually you let all the tests run in a suite, so you have one instance of Java,
Okay.
which is shared between the tests, so it can record everything. If it cannot record everything, it will tell you there are
Yeah,
missing
that's-
things.
So and now I should pass the real waiter. So yeah, I pass the waiter and I let it run.
Yes.
Oh no, we do not have a waiter yet.
Yeah, but
Let's create a waiter.
and here you can again just continue. You can again see how how harmless JavaScript is. Yeah, something is not there. It doesn't really complain. It just says it's not there. So it crashes at runtime. Maybe.
So we just create a waiter.
Okay.
Let it run again. Oh,
Order is not defined.
order is not defined. Let's define order. That's great. But now it should run. Our expected return value is Pizzadonna, but you returned undefined. So let's return Pizzadonna.
Yes. And in real life, this line would of course go to your production code.
I've just run the wrong. Now everything is okay. So yeah, of course that's not the real implementation what we wanted to do. The waiter doesn't create the pizzatono. He needs the chef. So what we would do is create a chef. Oh, no, for now we maybe we do some refactorings, because maybe we do not want to create it in that way, so I just copy
Yeah.
it.
But to make it quicker, we could also continue to the next test where the
Next
stuff
test?
is implemented. Yes.
Okay.
Or I think it's getting boring for you if we just do coding here, refactoring, stuff like that. So, because in the next step we have the waiter defined. Because the steps are steps in building up on each other. So if you scroll down,
So what we have is our waiter, who now and we now pass a test table, the chef, to the waiter, and we verified here. But because the chef is a test table, we have to assume what the chef does.
maybe you can show the production code of the waiter.
And the production code is that the waiter translate the order into an internal ID and asks the chef to make that meal.
Yeah, it's really a dummy implementation with a little bit of logic, but very trivial stuff.
And because we have now a new test table, the chef, where we only made assumptions, we have to do the verification again for the chef. So we go now deeper and deeper in our software layer down. And yeah, I just skip it.
Yeah, go to the last one, yeah. In the outside in stuff.
So the last thing is that we have a pantry which we pass to the chef and verify that the chef can handle the call make and returns pizzatono. This is the implementation of the waiter, and our chef he knows for each internal menu which ingredients he needs, and then he goes to the pantry and takes the ingredient, and then he creates the menu.
So we skipped that to not be too boring for you, also because I think there was lots of delays today and stuff. So let it run, and then everything should be green, right?
Let's run it. So we have two assumptions and two verifications, and everything is okay.
And all the implementations of the next layer below are driven by assumptions. So this is the cool thing here, yeah? Because you just say, I want to call my collaborator this way. It tells you, hey, but you don't have the ability to do that because there is no implementation that can handle that. And this is a cool thing, if you want to do the outside instead.
So, but now we are in the units, more inner units, and what we have done is we created a full pantry, but we now may think about what happens if we do not have a full pantry, if we, for example...
Do you know the situation, you come home, you want to cook something, open the pantry and it's empty? So, that's not good. If you would be a restaurant and somebody comes and says, I want a pizza, and you don't have cheese, you don't have tomatoes, what can you say? Sorry, forgot to go shopping.
So yeah, and we were maybe when we made the specification first, we didn't think about that, but now we think about it when we are in the down layers, that there are technical aspects or the error handling, and we now want to to translate that into a specification for the client.
It's in step 4, I guess.
Yeah. So sorry. So what we are doing is we make a new test where we throw an error, and we take the same arguments as in the successful case, but now we throw an error which says not available, and we let run that code. Now all our assumptions are verified, but we have one verification where the assumption is missed.
And this is the typical case, for example, when you have running code for the normal case. And then you're in the inner implementation and you find out, oh, there is some edge cases I'm missing, or there is some technical stuff, exceptions like here, which are missing, and then you try to integrate them. And then, of course, you have to handle them up to the level where you want to finish the handling. But if the exception now is called in integration, it will crash. So we don't know it because we don't have integration tests, because we don't like integrated tests.
So we now start to think about, okay, we should create an assumption. So let's
Command D.
see it.
D double.
Okay, let's create it. So what should our waiter do if the chef throws an error?
What should he do? Shout at the customer, right? That's good.
So maybe we ask the customer to choose something else.
Okay. So we are a polite waiter.
Huh?
And it's not a Russian waiter.
Something else. So now we assume that our chef throws an error. And I just copy. Is it not available? And our waiter now throws an error, 2 maybe, and I'm too fast typing.
Maybe say sorry or something.
Sorry,
That's it.
something else.
Yeah.
So I run this. No. Oh, we didn't have implemented it. So by now we return the error in the beta code.
Because it's not catched.
It's not catched. So now we should catch it here.
Try.
Try. Catch the exception, and then
Throw the other arrow.
arrow with the message.
Sorry, something else. So in the beginning, when I was working on this stuff, I was thinking, I'm just repeating myself, I'm just writing down what I've implemented, blah blah blah. But then I applied it to production code I had, and I found out that I had senseless tests there. There were tests, and on the other way there were the mocking for the tests, the stubbing, but they didn't play together well. So I stuffed something else what I was really testing, and it was not good. That was quite a cool experience.
So now we have a new verification which wasn't assumed, so we should do that for our add that to our customer, that our customer can handle this error. And I just skip the implementation. So yeah, the last step is that we write or add the specification that the waiter can throw an arrow, and if I run that, everything is okay and green.
Yeah, we skipped quite a lot of the mechanical typing, so it's not too blah blah blah.
So
yeah. So
was it a little bit too fast, or do you have any questions?
let's go back to the pictures.
So
Yes, because from our side, this is what we wanted to show you. We wanted to show you that we really want a high coverage by isolated tests, tests in isolation that are connected via some assume verify approach, but not only with integrated tests. And now we would say questions. Do you have some comments?
what do you think about it?
You can shout at us and say, you're weird.
How would you test asynchronous jobs? You do that?
Yes, it's in JavaScript you just give a callback as an argument, and then you can verify if this callback does something. Yeah. So that works.
You have only one layer callbacks.
Yes.
The problem is if you have more.
Yeah,
You
but
can
then you
only
should not.
grab one layer, one after the other.
And yeah, if you do the other thing that you mock and mock and mock, you have maybe a senseless test, because you should only mock one layer away. And what we often see is if the mock called some other code and we mock that, that's the thing why mocking has a bad reputation. So yeah, focus on one layer on the unit and the collaborator.